People say 5G is dangerous, but they are mixing up two completely different types of radiation. And here is the surprising part. Even at 140 GHz, something very important doesn't happen. It still cannot damage DNA. Before we go into the details, we need to understand one simple truth. Not all radiation is the same, like not all light is the same. All wireless technologies, FM radio, Wi-Fi, 4G, 5G, and even future 6G are part of something called the electromagnetic spectrum. This spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. They are all the same type of wave, but with very different energy levels. By the way, microwave is actually part of RF. We sometimes separate just to make the diagram easier to understand. Here is the most important concept in RF safety. There are two types of radiation. First, ionizing radiation, things like X-rays and gamma rays. These are powerful enough to break chemical bonds and even damage DNA. That's why they can be dangerous. Now, second, non-ionizing radiation. This includes radio waves, microwaves, and even 5G or 140 GHz used in future 6G. And here is the key point. These do not have enough energy to break molecules. They simply cannot damage DNA in the same way. So, when people worry about high-frequency signals like 140 GHz, the real question is not, is it ionizing? Because it isn't. The real concern is something else. And that's what we will break down next. So, where does RF actually sit in all of this? RF, or radio frequency, is firmly in the non-ionizing part of the spectrum. That means it behaves very differently from things like X-rays. Even when we go to very high frequencies, like 140 GHz, the energy is still extremely low. In fact, each photon at 140 GHz carries far too little energy to break chemical bonds or damage DNA. And this is the key idea. RF cannot cause the kind of damage that ionizing radiation does. So, when we talk about RF safety, we are not talking about DNA damage like X-rays. We are talking about a completely different mechanism. And that's what makes RF safety fundamentally different. So, if RF doesn't break molecules, what does it actually do? The main effect is heating. RF energy can cause small molecular motion, slight temperature increase. This is similar to how sunlight warms your skin, or how a microwave heats food. But here is the key difference. Communication systems operate at much lower power levels. When people hear the word radiation, they often think of something dangerous. But scientifically, That's incomplete. The real question is, what type of radiation and how much energy? RF from wireless systems is non-ionizing, doesn't damage DNA directly, and then behaves very differently from X-rays. So, if RF is non-ionizing, does that mean it's always safe? Not exactly. Because what really matters is how much power and then how close you are. In the next episode, we'll break down power, distance, and then real exposure. RF sounds scary, but here is the truth. It's not X-rays. It's non-ionizing, no DNA damage. At most, it just heats things up. Understanding this foundation is the first step to separating science from fear. Thanks for watching.